In this video, we'll see just how we evaluate a different constrained motion system with the implications of force and acceleration principle, that is the kinetics of the particle. Now, the system or the equation stated that the system is released from rest with the cable taut. For the friction coefficient, mu s is 0.25 and then mu k is 0.2. Calculate the accelerations of each body and then the tension in the cable. Neglect the small mass and the frictions of the pulleys. So in this example, the system is released at rest, and then if we just release the system, it will move in the upward direction or in the lower one direction. As you see over the animation, if the system is just moving or the block is moving in the upward direction, then the cylinder will be in the downward direction, or it will be in the vice versa direction. That means the cylinder will be in the upward and then the block will be in the down inclined plane. But we have to know that the positions of the cylinder, that is from the initial position to the final one, if it has the distance SB or distance of cylinder B, then the block will have a distance of cylinder A, and then it is known that it is 2 times the distance of the cylinder B. Because cylinder B has 2 variable lengths and then the block has 1 variable length. So from the constrained motion principle, if the cylinder is moving a distance SB, then the block will move double of that distance, and then the acceleration and the velocity will be also the same. That means distance of A is equal to times distance of B, velocity of A is 2 times velocity of B, and then accelerations of A will be also double of the accelerations of the cylinder. So this is the overall system, how the systems operate or how the systems work. So based on this equation, let's evaluate the accelerations of the two block and then the tension force under the cable. And then before starting calculating every analysis, we have to check whether the system is in motion or not, because there is a friction between the block and then the inclined plane, which in turn will resist the system for any motion. So the first thing is checking whether the system can move or not. Now let's see the solution part. First of all, we'll write the given parameter just like this one. So from the given part, we know that coefficients of static friction is 0.25 and then coefficients of kinetic friction is given as 0.2. We know that since the block is attached or move over the inclined plane, so we'll have a friction between the two objects. Since there is a frictional force, so what will be the implications of the system, or how we could just solve this one, will be continued. Before doing anything, we have to check whether the system is under motion or not, because there is a probability that the objects might not move due to the frictions between the block A and then the inclined plane. So let's check that whether the system is in motion or not. To do that, let's take out our required parameter and then let's just do how we could solve that one. Now the required parameters are, at the system equations here, we have to know accelerations of A, accelerations of B, and then the tension under the system. So all these parameters are unknown. Now let's solve this equation. To solve this part, let's take out the free body diagram into two parts. That means for cylinder B and then for block A. Now for cylinder B, let's take some notation. That means how the weights of the cylinder have an impact on the block to move it either the upward or the downward direction. So we know that this is a cylinder B, and then it will have its own weight. That means weights of cylinder B is equals to mass of B times gravity in the downward direction, and then in the upward direction we have two cables, so we'll have 2 times tension in the upward direction. So the weights of the cylinder is now becoming 15 times 9.81, and it will become 196.2 2 Newton. This is the weight of the cylinder. Now, since the object is just released at rest condition, that means at rest part, let's take out the equivalent tension force in that condition. That means summation of force in the y direction is equals to 0 because it was at rest in the first condition. So this implies that 2t minus weights of B will become 0, and then if you substitute the numerical value, 2t is equals to 196.2 and tension will be 98.1 Newton. So this is the equivalent tension when the system is at rest. Now let's consider for block A, let's take out the free body diagram just like this. It is inclined at a 30 degree and this is block A, and then assume the object is at rest and then try to move in the lower direction over the inclined part. So if the object had a tendency to go in the downward direction, let's take out this as a positive x-axis in the lower part. And then perpendicular to this, we'll have a normal axis. And then we'll have a tangent one over the inclined one. And then the tension is in the upward direction. We know this is tension. And due to the weights of the object, it will have the effects of the weight in the lower direction. Let's call this one as weight force. And then we know that the weight is in the vertical downward direction. This is weight of block A, and which is equals to 60 kg times 9.81, and then it will become 588.6 Newton. This is the weights of A. And then we know that this is angle theta, and then if this is angle theta, it will become also angle theta. And then we'll have a frictional force which is trying to oppose the system into the upward direction, so it will be frictional force, that means static frictional force, because the object is now considering at rest, and then we are trying to see whether the object could move with the implications of the overall force or not. We are trying to solve that one. This implies that now, if we sum up the forces into the normal direction, we'll get summations of force in the normal direction is equals to 0 because there is no any motion in the normal direction. This implies that in the normal direction, we know that the normal force is applied in this direction. This is normal force N. So once we have this, let's evaluate that. So N minus, now the weight component, that means the components of the weight into the normal direction will be the cosine functions of that portion. That means it will have this portion. This is weight in the normal direction. That means weight of A times cos theta. So N minus weight of A cos theta will become 0. This implies that the normal force is equals to the cosine function or the cosine values of weights of A. That means 588.6 times cos 30 degree. Now it will become N is equals to 509.74 Newton. This is the normal force. Once we evaluate the normal force, let's evaluate the frictional force. So the static frictional force is equals to the static friction coefficient times the normal force, and then if you substitute the numerical values with 0.25 times 509.74, so you will get the static friction as 127.44 Newton. This is the static friction force. And then the weight component in the vertical direction, that means the forces of weight Fw, which is in this direction. This is the weight component. This is the weight in the vertical direction, and the components of this weight into the x direction is written in this way. That means the weight components with the sine functions of the theta will be that value, that is this portion, so this is just Fw. So Fw is equals to W of A sine 30 degree. So we know that the weight of A, which is 588.6 times sine 30 degree. If you multiply that, we'll get W in the forces of the vertical direction become 294.3 Newton. So this is Fw. Once we evaluate these functions or these parameters, let's now evaluate whether the system is in motion or not. Now we can determine that. Now to do this, let's take out the free body diagram for block A. That means in this way, this is a block A, and then we know that this is static friction, this is tension, and this is Fw, and then we are assuming that the object has a tendency to go in the inclined, that means in the down inclined direction here. Just let this is as a positive x. So summations of force in the x direction of the down inclined is positive is equals to, in this case, Fw is positive minus tension minus frictional force. If we get this force, then finally we can determine that whether the system is in moving or not. Let's take this out. So we know that Fw is 294.3 minus tension is 98.1 minus frictional force is 127.44. Now if you evaluate this, we can get summation of force in the x direction is 68.76 Newton. So since this value is a positive in the downward direction, it indicates that the system is moving into the down inclined. So we are sure that the block is moving in the down inclined. That means the pulley system, in this pulley system, cylinder B will move in the upward direction, and then block A will move in the inclined down direction. Once we have all these concepts, let's evaluate now the accelerations of both systems. Now for cylinder B, we know previously the free body diagram as it is. This is 2T, and then this is weight of B for cylinder B. And then let's, since the object is moving in the upward direction, let the upward is positive. So summations of force in the y direction is equals to mass of B times accelerations of B. This implies that 2T minus WB is equals to mass of B times accelerations of B. If we substitute the numerical values, then we'll get 2T minus W of B is now 196.2, which is equals to mass of B is 15 times accelerations of B. In this case, we don't know about the tension because the object is under motion. Previously it was at rest, so since it was at rest, we evaluate the value of the tension, but in this case, since the system is moving in the upward direction, we know that the tension will be greater than the previous tension value. So, if you just simplify this, we'll get T minus 10 times accelerations of B is equals to 98.1. This is the simplified forms of the previous equation. Let's call this one equation 1. Now for the block B, let's evaluate the same thing. This is for a cylinder B. Now for block A, let's take out the free body diagram again. This is block A, and then we know there is a kinetic friction. Since we know that the system is under motion, we may not use a static friction force. Instead of that, we'll just use the kinetic friction force Fk. And then the tension is in the upward direction, and then the force due to weight is in the downward direction. Latest, the down inclined is positive x axis. So in this case, frictional force as a kinetic is equals to coefficient of kinetic friction times normal force. Then the coefficient is 0.2 times, and then the normal force is previously evaluated as 509.74. And then if you evaluate that, finally you will get 101.95 Newton. This is just the kinetic friction force in the upward direction, which resisted the motion to the downward direction. Once we have this, let's evaluate summations of force in the x direction, that means in the downward direction, is equals to mass of A times accelerations of A, because this is block A. We are evaluating the acceleration in the summations of force for the block A. So this implied that in the downward direction we have Fw minus T minus kinetic friction is equals to mass of A times accelerations of A. Just put the numerical values into this equation. We'll get Fw is 294.3 minus tension minus 101.95 is equals to the mass of the block is 60 times accelerations of A. If you simplify this, finally you'll get T plus 60 accelerations of A is equals to 192.35. So let's call this as equation 2. This is equation 2. Now from the constrained motion, we know that the velocity and the acceleration relationship between the two particles, that means since we have two variables for the cylinder B and then one variable length for A, we know previously that the velocity of A is equals to 2 times velocity of B, and the same thing, accelerations of A is 2 times accelerations of B. So considering this as it is, and then let's just add one more equation, that is accelerations of A is 2 times accelerations of B. So this is the third equation. Now we have 3 equations and 3 unknowns. The unknowns are tension, accelerations of A, and then accelerations of B. If you solve this equation simultaneously, finally we'll get the values of each acceleration and then the tensional force. Let's evaluate this again. Let's write equation 1 and equation 2. That means from equation 1, T minus 10 accelerations of B is 98.1, and then from equation 2, T plus 60 accelerations of A is 192.32. Now to cancel the tensional force, we can multiply the first equation with -1 and then we'll sum up the two. Then finally we'll get the relationship between accelerations of A and accelerations of B. Let's cancel out that parameter. Now if we multiply this with -1 and then sum up with the two parts, that means -1 times T will be minus T, and then if we sum up this, T will cancel out these parts, and then this negative will multiply this one, it will become positive, and then this part is now positive, but if you multiply with this -1, so it will be -5. So in this case, finally if you sum up them, you will get 0 plus 10 times accelerations of B plus 60 times accelerations of A is equals to minus 98.1 plus 192.32. If you simplify this further, then you will get 10 times accelerations of B plus 60 times accelerations of A is equals to 94.25. Now this is additional equation. Now if you substitute the value of accelerations of A or accelerations of B from equation 3 into this equation, then we can simplify one of the two accelerations. Accelerations of A is equals to 2 times accelerations of B. Let's substitute this into this equation. This implies that 10 times accelerations of B plus 60 times accelerations of A is 2 times accelerations of B, which is equals to 94.25. This means 10 accelerations of B plus 120 accelerations of B is equals to 94.25. Then if you sum up these two parts, it will become 130 accelerations of B is equals to 94.25. That means divided this with 130 and then this one 130. Finally, you'll get accelerations of B is equals to 0.725 meter per second square. This is our answer because this was the required part. So this is answer. Now let's go to the next unknown parameter, which accelerations of A. We know that accelerations of A is equals to 2 accelerations of B, which is equals to 2 times accelerations of B is 0.725, and then accelerations of A finally will become 1.45 meter per second square. This is also our answer. Now, the last unknown parameter is tension. So we can substitute the value of accelerations of A and the accelerations of B, either of the equation 1 or either of the equation 2. Let's substitute it on the equation 1. We know that from equation 1, tension is equals to 98.1 plus 10 times accelerations of B. So this is from the equation 1, just like this. Now once we have that, let's just substitute the numerical value and then let's see what will happen. So tension finally will become, so tension is equals to 98.1 plus 10 times accelerations of B in this case is 0.725. So if you just calculate this one, it will become 98.1 plus 7.25. And then if you sum up them, finally you will get tension is 105.35 Newton. This is our final answer for the tension. So we are evaluating the value of accelerations of A, accelerations of B, and then the tension in the rope. So this is it.